In this lecture, we take the example based on the reduction formula of cos to the power nx dx. Question is, if in is equal to integration of cos to the power nx dx under the limit 0 to pi by 3, then prove that in is equal to root 3 upon n into 2 to the power n plus n minus 1 upon n in minus 2, and using it to find I6. So we have to first find out the reduction formula of this function, this integral, and that will be nothing but this. And after finding this thing, we use this formula to find out the value of I6, means we have to just put the value of n over here, then we are able to calculate the value of I6. We have given that to find the reduction formula for cos to the power nx dx first. So here this is not indefinite integral, it is definite integral. So let us put in is equal to integration under the limit 0 to pi by 3 of cos to the power nx dx. So in the last lecture, we have already taken how to find out the reduction formula of cos to the power nx dx. For this purpose, we have to break cos to the power nx into two parts, cos to the power n minus 1x and cos x. So now if in is equal to this, then we have to prove that in equal to root 3 upon n into 2 to the power n plus n minus 1 upon n in minus 2. Now from 1, we have in is equal to integration of 0 to pi by 3 and integration of cos to the power nx dx under the limit of 0 to pi by 3. So now we are breaking, this comes double. We are breaking cos to the power nx as two part cos to the power n minus 1x into cos x dx. So this is our first function u and this is second function v. So we apply the integration by part using this formula. Integration of uv with respect to x is equal to u integration of vx minus integration of derivative of u with respect to x into integration of v dx and whole integration of this with respect to x. Now, first function cos to the power n minus 1x, integration of cos x is sin x. And now since there is a limit over here, so we have to put the limit 0 to pi by 3 minus integration under the limit 0 to pi by 3. Derivative of cos to the power n minus 1x is nothing but n minus 1 cos to the power n minus 2x, and again derivative of cos x is minus sin x, and integration of cos x is nothing but sin x. Let us once again take it. First function cos to the power n minus 1 x, integration of cos x is sin x under the limit 0 to pi by 3 minus integration of derivative of cos to the power n minus 1x. It is nothing but n minus 1 into cos to the power n minus 2x, and derivative of cos x is minus sin x, and again the integration of cos x is sin x. So if we substitute the limit over here in the first part, cos pi by cos to the power n minus 1 x is equal to pi by 3 into sin pi by 3, it is upper limit. And if we put the lower limit, then of course the cos 0 is 1 but sin 0 will be 0, so ultimately it will become 0. So I have only written the final value 0, and this minus and this minus will become plus, and it is just like n minus 1 integration of cos to the power n minus 2x into sine square x with respect to x. Now again we can write down sine square x in terms of cosine x, so we can write down. And before that, what is the value of cos pi by 3? Cos pi by 3 is 1 by 2. So 1 by 2 whole to the power n minus 1 into sine pi by 3 means sine 60 is root 3 by 2 minus 0 plus n minus 1 integration under the limit 0 to pi by 3 of cos to the power n minus 2x, and this sine square x can be written as 1 minus cos square x. Let us let us solve in the next step. Okay, so now that we have taken the same thing in the first step. Now in the second step, 1 by 2 to the power n minus 1 root 3 upon 2. So we can write down root 3 in the numerator and 2 to the power n minus 1 into 2. So we can write down 2 into 2 to the power n minus 1. And the next part is into plus n minus 1, 0 to pi by 3. If we multiply this with 1, it should be cos to the power n minus 2x dx minus, because this is plus and this is minus, so minus this cos square and cos to the power n minus 2. So minus 2 and plus 2 will cancel and we have only the cos to the power nx dx. So if we see, this is nothing but in, this is in minus 2, this is in minus 2. So if we put all these values, we have root 3 upon, this is 2 to the power 1 and 2 to the power n minus 1. So plus 1 minus 1 will cancel. We have 2 to the power n plus n minus 1 in minus 2 minus in minus 1 into in. Because in is equal to nothing but integration of cos to the power nx dx under the limit 0 to pi by 3. Now since left hand side is in, so we transpose this in terms to the left hand side. So we have in plus n minus 1 into in, which is equal to root 3 upon 2 to the power n plus n minus 1 into in minus 2. Now we can take in common from these two things. So if we take in outside from here, we have only 1 remaining. And in this place, n minus 1 is remaining. So minus 1 plus 1 will cancel. And this side, no change. We can write down as it is root 3 upon 2 to the power n plus n minus 1 into in minus 2. So this 1 and minus 1 will cancel. So n into in is equal to root 3 upon 2 to the power n plus n minus 1 into in minus 2. Now we have to find the value of in. So we have to divide whole equation by n. So we have root 3 upon 2 to the power n into n plus n minus 1 upon n into in minus 2. So this is the desired reduction formula for the given integration. In is equal to integration under the limit 0 to pi by 3 of cos to the power nx dx. Now, this is the first part of this question. The second part is we have to obtain the value of I6. So now in this reduction formula, if we put the value of n equal to 6, we are able to calculate the value of I and I6. So now we have to find the value of I6, which is equal to integration of cos to the power 6x under the limit 0 to pi by 3 with respect to x. Putting n equal to 6, 4 and 2 in equation number 2. The equation number 2 is nothing but in is equal to root 3 upon n into 2 to the power n plus n minus 1 upon n into in minus 2. So here we have to first put what is the value of n equal to 6. So what will happen? This is I6 root 3 upon 6 into 2 to the power 6 plus 6 minus 1 upon 6, 6 minus 1 upon 6 and I6 minus 2. So if you simplify it is root 3 upon 6 into 2 to the power 6 plus 5, 6 minus 1 is 5 upon 6 into I to the power 4. Now, so I6 is reduced to I4. Now we have to calculate the value of I4. So in the same formula, we have to put n equal to 4. Then we have I4 is equal to root 3 upon 4 into 2 to the power 4 plus 4 minus 1 upon 4 into I4 minus 2. That can be written as root 3 upon 4 into 2 to the power 4 plus 4 minus 1 is 3, 3 upon 4 into I2. Now we have to again calculate the value of I2. So for finding the value of I2, we have to put value of n in this reduction formula. So we have I2 is equal to root 3 upon 2 into 2 to the power 2 plus this is n equal to 2 minus 1 upon 2 into I2 minus 2, which is equal to root 3 upon this is 2 into 4 is 8 plus 1 by 2 into I0. Now, how to calculate the value of I0? So now the given formula in In, we have to put the value of n equal to 0. So now putting n equal to 0 in equation number 1, we have I0 is equal to integration of cos to the power 0x under the limit 0 to pi by 3 with respect to x, and cos to the power 0x, x is nothing but 1. So integration of 1 is x under the limit 0 to pi by 3. And if we put the upper limit and lower limit, so pi by 3 minus 0, which is equal to pi by 3. So the value of I0 is pi by 3. So now we have to put the value of I0 in the equation number 5, and then we get the I2, and the value of I2 is substituted into the equation number 4. We get I4, and the value of I4 if we substitute in equation number 3, we are able to say what is the value of I6. So let us do the reverse engineering over here. Putting the above values in equation number 5, 4 and 3, we have I2 is equal to, what is the value of I2? It is root 3 upon 8 root 3 upon 8 plus 1 by 2 into I0, root 3 upon 8, 1 upon 2, I0 is nothing but pi by 3. So this will become root 3 upon 8 plus pi by 6. This is the value of I2. Then let us put the value of I2 in the equation number 4. Here we are able to calculate the value of I4. So I4 is nothing but root 3 upon 4 into 2 to the power 4 is 16. So 16 4 ja 64 plus 3 upon 4, and the value of I2 is root 3 upon, this is the value of I2, root 3 upon 8 plus pi by 6. Now, then this can be written as root 3 upon 64. We are writing this as it is. And then 3 root 3 upon 4 8 ja 32. And then plus 3 pi by 4 6 ja 24. So 3 1 ja 3 and 3 8 ja 24. So this, if we take the LCM of these two things, LCM is 64. So 64 1 just 64 root 3. This is root 3 plus, if we divide 32, 64 by 32, it will become 2. So 2 into 3 root 3. So this is nothing but, this is 3 is an 3 2 just 6. 3 2 just 6 plus 1. 7 root 3 upon 64. And this is pi by 8. So this is the value of I4. Now we have to substitute the value of I4 in equation number 3. We have I6. So I6 is equal to root 3 upon 6 into 2 to the power 6 is nothing but 384 plus 5 by 6. This 5 by 6 into I to the power 4 is 7 root 3 upon 64 plus pi by 8. Now, if we multiply this, 5 into 7 is 35 root 3 upon 6 into 64 is nothing but 384 plus 5 pi by 6 8 ja 48. So if we simplify, this is what it is, nothing but this is 1 plus 35 is 36. So 36 upon 3, 36 root 3 upon 384 plus 5 pi by 48. And if we simplify this, 36 divided by 384 root 3. So this is 3 1 ja 3, 3 2 ja 6, 3 1 ja 3 2 ja 3 1, sorry, 3 1, okay, 3 1 ja, 3 2 ja 6, 3 8 ja 24. Again, if we divide by 4, so 4 3 ja 12, 4 3 ja 12, 4 2 ja 8. So 3 upon 32 is the last part. 3 upon 32 root 3 up plus 5 pi by 48. So this is the final value of I6. I6 is equal to integration of cos to the power 6x dx with respect to under the limit 0 to pi by 3, which is given by 3 root 3 upon 32 plus 5 pi by 48. So this is the value of I6. This is the desired result. Thank you.